morning everyone. My name is Nikhil. I am from CSC D section. Today I am going to present about H2O2 and methanol O2 fuel cells, their construction and working. First, introduction. Fuel cells are modern electrochemical devices that convert chemical energy directly into electrical energy. Unlike engines, fuel cells do not burn the fuel. Because of this, they produce electricity cleanly and efficiently. Fuel cells are very important today because they give clean energy, they have high efficiency, and they produce almost no pollution. Hydrogen fuel cells release only water, so they are considered a green energy source. Fuel cells are used in vehicles, backup power systems, and portable devices, and even spacecraft. Principle. The basic principle of a fuel cell is a simple redox reaction. Fuels such as hydrogen or methanol is oxidized at the anode and oxygen is reduced at the cathode. Because of these reactions, electrons travel through an external circuit and that flow of electrons produces electricity. So the principle is chemical reaction to electron flow to electricity. H2O2 cell construction. Now let us see the construction of the hydrogen oxygen fuel cell. It mainly contains anode, usually made of porous platinum, cathode also made of platinum electrolyte, often potassium hydroxide or polymer electrolyte membrane. Fuel hydrogen gas, oxidant oxygen gas. The electrodes are porous to allow gas movement and the electrolyte separates the anode and cathode. H2O2 fuel cell working. Hydrogen gas is supplied to the anode. At the anode, hydrogen molecules split into protons and electrons. The protons move through the electrolyte, but electrons cannot pass through the electrolyte, so they travel through the external circuit. These movement of electrons generate electricity. At the cathode, oxygen combines with the electrons and oxygen ions to form water. Thus, the fuel cell continuously produces electricity, water, and heat. Fuel cell reactions. The reactions in the hydrogen oxygen fuel cell are anode reaction. H2 gives rise to 2H plus ions plus 2 electrons. Cathode reaction. O2 plus 4H plus 4 electrons gives rise to 2H2O. Overall reaction 2H2 plus O2 gives rise to 2H2O. This shows that water is produced, making it a clean energy system. Advantages of H2O2 fuel cell. The hydrogen oxygen fuel cell has many advantages. It produces clean energy with almost no pollution. It has high efficiency and works continuously as long as fuel is supplied. Methanol O2 fuel cell construction. Now coming to the methanol oxygen fuel cell, its mainly parts are anode, cathode, electrolyte, fuel oxidant. First, cathode with a PTRU catalyst. Cathode usually platinum, electrolyte polymer membrane, fuel methanol mixed with water, oxidant oxygen gas. Methanol is liquid, so it is easier to store and handle compared to the hydrogen. Methanol O2 fuel cell working. At the anode, methanol reacts with water and gets oxidized. This releases electrons and hydrogen ions. Electrons flow through the external circuit producing electricity. At the cathode, oxygen gas combines with the hydrogen ions and electron to form water. In this fuel cell, carbon dioxide is also produced as by a product. The reactions in the methanol fuel cells are anode reaction. CH3OH plus H2O gives rise to CO2 plus CH plus 6 electrons. Cathode reaction 3 by 2 oxygen plus 6 hydrogen plus 6 electrons gives rise to 3H2O. Overall reaction CH3OH plus 3 by 2 O2 gives rise to CO2 plus 2H2O. Comparison. Now let us compare the two fuel cells. Hydrogen fuel cell is cleaner because it produces only water. Methanol fuel cell is easier to use because methanol is liquid and easier to store. Hydrogen fuel cells have higher efficiency. Methanol fuel cells are cheaper and safer for storage. Conclusion. To conclude, both hydrogen, oxygen, and methanol oxygen fuel cells are important future energy technologies. They produce electricity through simple chemical reactions and reduce pollution. Hydrogen fuel cells are ideal for clean energy systems, with methanol fuel cells are useful where easy fuel storage is needed. Thank you.